Hey folks, welcome back. We're talking dynamics, we're talking particle systems, and we are looking at an angular momentum example this time. So as promised, we're going to talk about some angular stuff. We have a system given particle A, B, and C. Each particle has a corresponding weight, and we're given the velocities. The velocity of B is given in terms of variables Vx and Vz, with the y component being 2 feet per second. We're asked to solve the system for Vx and Vz in particle B when the total angular momentum is parallel with the x-axis, and then to also get the value of the total angular momentum. So what that means is that we're going to need to add it up and then use the fact that it's only in the x-axis to find the values that we're looking for. In order to do that, we need to have the position of each of these particles. So let's start there. So our sub A is, where is that? A is right here. So 0, 5, 4. And particle B is here, so 4, 4, 3. Our sub C is along the x-axis, so 8, 6, and 0. Okay, and now we can start putting these together. In general, what we can do is pull the mass out and write it as the weight over gravity. So H naught, hopefully my pen will make it, if not I'll get another one. We'll go 5 over G, then I, J, K. And we're going to end up having to do the Cramer's rule 3 times. That was sad. I don't know what that line was all about, but I had a mind of its own. So 0, 5, 4, 2, 3, negative 2. Okay, plus for particle B, we have 4 over G. And then again, I, J, K. All in hats. R is 4, 4, 3. And V is V sub X 2 V sub Z. And finally, particle C, 3 over G, I, J, K, hat, 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 and 860. That's where it's at. Where's it going? It is going -3, -2, and 1. And let's add these. So first things first, let's move gravity over to here. Just get it out of our way. All right, so let's see. -10, -12 is -22, times 5 is -110. The J direction we have 0, -8, times 5 is -40, so plus 40 J. The K direction we have 0, -10, times 5 is -50 K direction. Then on to the next one, we have for the I direction, we have, put these in parentheses because there's going to have variables in each one of them. So 4 times V sub Z times 4 is 16. Vz minus 6 is 4 is 24. I direction. In the J direction. See, in the J, we've got 4 times Vz, so 16. Vz minus 12. Vx. So j direction, k direction, we're going to have 8, 32 minus 16 sub x, k direction. And finally with this guy, we've got in the I direction at 6 times 18, so 18I minus 8 times 4 is 24. J. And the K, we've got minus 16 minus a negative 18, so 2 times 3 is 6. Okay. So now we should be able to divide these according to the direction, right? So in the I direction, we have G H naught is equal to minus 110 plus 16 v sub z minus 24 plus 6. And if we put these together, we get H naught equals, let's see, that's minus 134. Well, this is 18, right? Minus 24 others. So minus 128 plus 16 pz. Okay, in the j direction, we're going to have 40, 0 equals 40 because there's no component of the angular momentum that's in the j direction. So that's going to equal 40 minus 16 vz plus 12 vx minus 24. It's going to be equal to 0. I can already tell we're going to be able to divide this out by 4. So let's see. Let's move the numbers to the other side. So 40 minus 24 is 16 divided by 4 is going to equal 4. So let's put equals 4 here. Then 3 v sub x minus 4 v sub z is equal to 4. So that's helpful. That's a lot better than this stuff up here. K. Okay, so again, 0. We got minus 50 plus 32 minus 16 v sub x plus 6. And that again equals 0. Oh, sweet. We only got the Vx here. And so minus 50 plus 32, 6 is 12. So let's see. That's going to give us 16 v sub x. I add this across equals minus 12. Well, that's going to give me v sub x is equal to minus 0.75. Sweet. Okay, well, I can substitute that in up here, right? And when I do that, what do we get? Let's see, 3, 0.75 minus 4 is that? It's 4. So what is this? That looks like 2.25, right? 3 times 0.75. Yeah, 2.25. So 4 minus that is going to be 1.75. So Vz is 4 divided by, wait, I'm sorry. That's not right. It's 1.75 divided by 4, right? And so that's going to give us that VZ is equal to 0.4375. And that's in feet per second. Okay, and finally, we can use that here. So I guess make a big arrow here. So H naught. Now it makes sense to use the gravity. So it's going to be 1 over 32.2. And it's going to be times minus 128 plus 16 times 0.4375. Okay, and when you calculate this, then you get H naught equals, where's it at? Minus 3.39 feet per second per pound. And that's in the I direction. Okay, so not a lot of challenging concepts there, but quite a bit of note-taking, or excuse me, bookkeeping. So let's see, we got those two circled. Let's circle this one. And there you have it. So again, chapter 14 isn't bad from a conceptual loading point of view, but at least for the first part of it, there's quite a bit of stuff to write. So we'll move into slightly more complex systems in the next video. So hope you enjoyed.